Hello my dear friends. So we are going to solve the Boolean parenthesis problem. In the last video we have seen the recursive approach, and in this video we are going to check the memoization approach. So why do we need memoization? So what happens is, suppose this is our main problem, which is going to divide it into some small sub problems like this further. Okay, so suppose there is a function call. Suppose the function is for n minus 1. Okay, so for n minus 1 function, what we have done, we have solved this entire subtree. Okay, this entire subtree is solved for n minus 1. And suppose if you got the same n minus function call later, so you have to again solve the same function. So to avoid this again solving of the function, what we are going to do, so as soon as we are going to solve any problem, we are going to store that value in some dp. Okay, we are going to store that at some dp. And next time, first of all, whenever we get the same problem, we are going to check in the dp whether that problem is solved or not. If the problem is solved, then we are going to extract that value from the dp, and then we are directly going to return the solution. And suppose if the problem is not solved, okay, if the problem is not solved, at that time we are going to use the same way to solve the problem, and after the problem is solved, we are again going to store that value. So basically what we are going to do, we are trying to reduce the recursive steps, so it will reduce our time complexity. Okay, so this was the main idea before the memoization approach. Now how we are going to use memoization approach here? So as you have seen, we were using function, okay, like this, def, and the function name, let's say parent, and we were passing string I, j, and is boolean, is true. Okay, these were the three things which we were referring. Okay, so as you can see, the I was changing, j was changing, and is true was changing. I will show you the recursive approach. If you are directly coming to see the memoization approach, you will not get it. You have to watch the recursive solution first, then it will be a bit easier for you. Okay, so as you can see, this was our main function solve we have written at that time. Okay, so in this function, if you are going to see, here it is I, then it is becoming k plus 1. It means I is changing. Similarly, here it is k minus 1, then it is becoming j, so this is also changing. Here it is true, then it is becoming false, true, false. So it means we have three variables. So here, earlier in the previous questions, we always making 2D matrix, because we have only two variables I and they that were changing. Because suppose this is I and this is j, so we were making the dp of n plus 1 comma n plus 1. N is the size of string, okay, length of string. Perfect. But here three variables are changing. Okay, the last variable is true, which can have two values, true or false. So we need to store these two values as well. So if we have two variables, we were using the 2D matrix. Now we have three variables that are changing. So what we are going to do, we are going to use 3D matrix. Okay, so what will be the size of the 3D matrix? It will be same dp of n plus 1, n plus 1, and 2. Why 2? Because we have only two values in is true, either true or false. So this is the 3D matrix concept that we are going to use. I think till now we haven't used this concept, but we are in this question we will be using this concept. So you don't have to be scared that this is 3D matrix, how we are going to solve this. There are some few tweaks that we have to do. Rest everything is same that we have done in the 2D matrix. So instead of searching in 2D matrix, now we need to search in the 3D matrix, that whether that element is solved or not. And after, as soon as the elements are solved, we need to pass that value in the our, what we can say, matrix. Okay, so let's write the solution. Okay, so if you directly come to the solution, I will recommend you to watch the previous one, because then only you will know that how we have got the value of I and j, what is the base condition, because they are not going to change. They are not going to change. What is loop for k, and how with the temporary solution we are getting the final solution. So these four steps will be same as there they were in the last problem, but the main twist is that before checking for the solution, we just have to check whether that problem is solved or not. It means you have to must watch the recursive approach first. Okay, so I am doing only a few tweaks in the last solution so that you can get it. Okay, so first of all we need to initialize the 3D matrix. So how we are going to initialize the 3D matrix? So there we were using -1. We are going to initialize with -1 for k in range of 2. This is one dimension. For I in range of, this is n plus 1, because n is the size of matrix. This is second dimension. And for j in range of n plus 1. So this is the way to declare a matrix in 3D. So what is the new step here? This line extra. Okay, for k in range of 2. This is the thing that is extra here. Earlier we were using -1 for I in range of n plus 1 and for j in range of n plus 1. So this is extra this time. So this is done. Now what we are doing, now let us define our function. So I am declaring this dp outside the function because to make it as global. So let us write the function solve, which is going to pass string I, j or string. These are the three variables that we are going to pass. So first of all, the base condition. So I told you base condition will be same. If I is greater than j, what we are going to do? We are going to return 0. I greater than j means this is our string. This is I and j. So I represents the starting point and j represent the ending point. And we know that I value will be 0 and j value will be length of string -1. So while calling the function, you can pass the I value as 0 and j value as length of string -1. So I represent the starting value and j represent the ending value. So starting value is always less than the ending value. But here if the starting value become greater than the ending value, it means that string does not exist. So we are going to return it as 0. Okay. Now there may be possibility there is only one element, okay, in the string or array. So if there is only one element, then we have to check whether that element is true or false. Okay, here we have one element. I don't know what is the element. There are two possibilities whether it is true or false. So we have to check if the element is true. And here if we require true in the question and the element is true, it means we got the what we want. And if here in is true is false and the string value is also false, then also we got the thing that is already required. In rest of the cases we are going to return 0. So here again we have two cases. If is true equal to 1, so what we are going to do, return 1 if string of I is also equal to true. Else what we are going to do, we are going to return 0. So what does this statement say? Suppose if you require true and here also it is true, so return 1, otherwise return 0. Okay, else what we are going to do, we are going to return 1 when we are going to return 1 if string of I is equal to false, else return 0. So what does this mean? Suppose if this is else for this if, okay, these two else. So if it is true and true, then return 1. If it is false and here also it is false, then return 1, because required is false and we already have the false. So this is the same condition that we have solved, because that was the same condition, right? Till now we are doing the same thing. Now before entering to the solution, as you can see, this is the recursive approach. So here we have done the same thing, right? This is done. I and j, we have done the initialization. Now we are entering into the loop of k. So before entering into the loop of k, what we need to do is we need to check whether that tree is solved or not. Okay, so that we have to check this time in the 3D matrix. Okay, so till now this is the function that we have done. So let us write for the case when whether it is solved or not. Okay, so in Python we need to make the indentation proper. Okay, so now what I am going to do, I am going to check if dp of I comma j and is true, true, is not equal to -1. Suppose in the 3D matrix that we have created, so 3D matrix will be in the form of cube. Okay, let me try to draw and help you. So it will be something like this. Okay, it's difficult to imagine, but okay, we don't require to imagine also. Okay, suppose you imagine like this. So where there is one more dimension, okay, which is storing the value. So if that is not equal to -1, what we are going to do, we are going to do the same thing. We are going to return that element dp of I comma j and is true. So what we have done is, initially we have initialized each element with the -1. If it is not -1, suppose here it is 7. So if the element is not -1, return this 7. Okay, no need to solve the dp. So our question is done here. As soon as you return, the function will end here, and okay, now this is done. Suppose if the element is not exist, so what we want, we are going to do the same step that we have done till now. So what we are going to do now, we are going to use the temporary answer. So temporary answer, initially let's say the value is 0. So again we are going to use the for loop for k, because that step is same. So for k in range of, so first of all we are going to start from I plus 1 to j, and we are going to jump two values at a time. I told you in all the questions we were moving k plus 1, but here we are going to move plus 2 every time. And why we are going to do plus 2, you can watch in my previous video. Okay, so this is done. Now what we need to check, so here we were finding 4 temporary values. If you are going to see, we were finding left true, left false, right true, right false. Okay, so here we have entered in this loop. So left true, left false. So before solving these functions, what we are going to do, we are going to check whether that subtree is solved or not. So what it will do, eventually it will reduce more number of recursive call. So if you do only check at the starting of the function, then it will reduce a little bit calls, but there might be some possibility that this subtree is already solved, this subtree is already solved, this subtree is already solved, or this subtree is already solved. So whenever we are going to do the recursive call, before that recursive call we have to check whether that is present in our dp or not. So everything will be same, just you have to check whether that value is solved or not. Okay, so here I am going to check if dp of I comma k minus 1 to 1 is not equal to -1. So 1 stands for true and 0 stands for false. I hope you can you know this very well. So left true will be equals to, if it is not -1, so what we are going to do, we are going to store that value in the left. Okay, this is done. Else what we are going to do, if it is not, then we are going to call left true as, again the left true will be solve function. We are going to call solve function passing str I k minus 1 and value 1. Okay, so what we have done is, we have called this function, right? I to k minus 1 true. So before calling this function, I have just checked whether it is value is present or not. So in this step we have just checked whether the value is present or not. So similarly we have to do this for all the 4. So here we have done the 4 calls, right? Sorry, yes, here we have done 4 calls. So first check is done. Now we have to check for the rest of the 3. So let us come here and write if condition for everything. So if dp of I k minus 1, now we have to check for the 0, because we have checked for the true value. Now we need to check for the value of the false if it is not equal to minus 1. So again what we will do, we are going to check left false first. So left false, lf will be equals to if it is not equal to minus 1, we are going to directly return the value. Okay, so lf will be equals to dp of I k minus 1 comma 0. Else what we are going to do if that is not present? So lf will be equals to same, call the left function I k minus 1 and passing 0 this time. Okay, this is done. So this is done for first, this is done for second. Okay, so now what we are going to do, we are going for the next value. So third one will be if dp of I this time I will be changed, so it will become k plus 1 to j. And first of all let us check for 1. If this condition is true, so what we are going to do, we are going to pass the right true this time, right? So right true will be equals to dp of k plus 1 j and 1. If that value doesn't exist, so right true will be solve function passing the string I value, j value and is true value. So these are the 3 calls that are done. So this is one, and one more last call if dp of k plus 1 comma j bracket 0 is not equal to minus 1. So again what we are going to do, right false we are checking now because it is 0, here it was 1. So right false will be dp of k plus 1 j 0. Else what we are going to do, right false will be equals to, let us call the function solve again, passing str k plus 1 j 0. Okay, so this is the function, all the 4 function for this was the third, fourth. So as you can see, this is the first, this was second, this was third, and this was fourth. So extra step what we have done is we just checked this. Okay, we checked the condition if that is already solved or not. Okay, if the function is already solved, then it will be good, otherwise okay. So this part is done. Now rest is everything same, rest solution is same, rest solution same. So if you want, I can write here also, but the question is completed here. The rest solution will be same means now we are going to write these conditions for the true, false. Okay, these are the 3 conditions. So this is the condition for OR, this is the condition for XOR that we have to write, and this is the condition for AND, this we have to write. So these are the 3 conditions that we are going to write now. So I will again write. If you know these conditions, you can skip this video, otherwise you can, if you want to revise, you can also continue in the video. So now what we are going to do, we are going to check if str of k equal to AND. Okay, right. So again if it is AND, so we have to check whether is true is equal to 1 or not. If the thing required is AND and we want 1, so what will be, it will become temporary answer will be temporary answer plus left true multiply by right true. So what does it mean? It means that in between the 2 problems that are solved, we have AND, and we want final answer as 1 means true. So in AND condition, only one case is possible, that left tree also should be true and right expression should also be true. In that case only we are going to get final answer as true. This is the statement of this meaning. Else if it is not, then we are going to write the rest of the 3 cases. What are the rest of the 3 cases? Rest of the 3 cases are there might be possibility that left true, right false, right false. Okay, so it is like left true multiplied by right false. There may be possibility that it is right to true and left false. There may be possibility that left false and right false. So we are going to add all of them. So this is the condition for AND. This was the condition for AND. Now let us write the condition for OR. So else elif, in Python we use the word elif. If elif of k is equal to AND, okay, and again if is true equal to 1, so it means finally what is the true expression are given to us, and OR is given, and finally what we want true. So when if OR is given, so at least one of them should be true. So we can write the condition for that line. So temporary answer will be equals to temporary answer, so any one of them will work true. So left true multiplied by right true, this is the possible case. Left true multiplied by right false, or left false multiplied by right true, this is the possible case. So these are the three cases that are possible. Else what we are going to do, else temporary answer will be equals to temporary answer. When this condition will become false, when both left and right are false, at that time this condition will become false. So this was the case for OR. Now we have to check the case for XOR. Okay, elif str of k equal to XOR. Okay, again if is true equal to 1, so when XOR is true, suppose this is first expression, this is second expression. If the first expression will give value true, second will give false, then XOR will be true. If first expression is false, second is true, then also value will be true. Okay, these are the two conditions when we are going to get final solution as true. If both the expression give the same value, either true or false, in that case we are going to receive final answer as false. So here what will be the temporary answer? Temporary answer will be equals to temporary answer left true right false, or left false right true. Okay, else temporary answer will be temporary answer, and this time I told you both should be same, left true and left right false, right true and left false and right false. So this is the temporary answer for the XOR, right? This is done. So after all the iterations, okay, all the else if these three iterations, what we need to do, we need to store this temporary answer into our dp. So dp of I comma j comma is true. What we need to do, we need to, I told you na, as soon as we solve any sub problem, so before returning we need to store that value in the dp. So in this step what we are going to do, we are going to store that value in the dp, and then what we are going to do, we are going to return that temporary answer. Perfect. So this is the our question completed here. So if we are going to see, we have done nothing new in this question. Nothing new in the sense means only one thing that we have, only few things we have done new. First of all, what we have done new, that this should be a 3D matrix. Okay, and every time before the function call where you are checking whether it is equal, the value is already there in the 3D matrix or not. If the value is not present in the 3D matrix, solve as we are solving normally, and if the value is present in the 3D matrix, directly return the value. So here we were directly returning the value as it was already present. Here we also directly returning the value. Here also we were directly returning the value, and here also we were directly returning the value. And then we have got all the four variables, left true right, left false, right true right false. Then we have used the same condition that we have used for the recursive approach, no change in the condition. And finally, before directly returning the solution, we are storing them in the dp. So this is also one additional step. So if you are going to see, we have not much additional step. So basically before the recursion call we just checking whether that value exists in our DP or not. So I hope you got this question very clear. Still, if you have any confusion, please let me know in the comment section. I will try to help you at my best. Thank you.